Hello and welcome back. So in the previous video, we used this code here to detect when a button has been pressed, and then in response to that, we turned on an LED. And I shared with you the truth that this is a bad way of detecting button presses in your firmware. I gave you at least two reasons. The first one was because of what we are doing on line 31 here, where we are constantly pulling, or we are making the CPU constantly check whether the button has been pressed or not, right? And that made it necessary for us to introduce this artificial weight here, which isn't so good. The other reason I gave was this check right here. If button state is less than 0, continue. Basically, I told you that when a button is pressed, because of the mechanical nature of these switches, sometimes they are neither high nor low and they float in between, and you really want to ignore those ones, right? So to properly understand that, I'm going to show you a circuit, and then we also look at what the problem is on an oscilloscope. Then I will suggest a very simple way of also solving that situation. So if we come here, this circuit right here is a simple way of setting up a switch, right? So basically this one is a pull up resistor. This is the switch here, and we are tapping the output from here. So when this switch is not pressed, we are going to read a high, right? But when it is pressed, because electricity always likes the path of least resistance, then it is going to be connected to ground instead of being connected to the positive 5-volt up here. So pressing or releasing this button is going to toggle this output between 5-volt and 0-volt. Now let's go to, let me show you what I have done here. So I have set up this circuit, the circuit I showed you. Forgive me for how ugly this looks, but I'm basically using a Digilent analog discovery as my oscilloscope, and I have set up the circuit that I showed you, and I have connected. So this is the pull-up resistor going to the positive rail. You can see it from here, and then the other side of the switch is directly connected to the ground, and then I'm tapping the output from here. So this is basically this circuit right here that I showed you. Okay, now let's come to the oscilloscope and let's see something interesting that can happen when a button is pressed or when a switch is pressed. It's not always that it happens, so I'm going to press it a couple of times until I see the situation, then I will use it to explain to you. So I press this, it happened but not so well, so I'll keep trying. Yes, this is a good one. All right, so you see the switch has been set up to output a 5-volt when it is not pressed because it's a pull-up resistor. I'm using a pull-up resistor in there. And then when you press the switch, I expect that it's going to pull it down to 0. So you see that it's toggling between 5 and then 0-volt right here, right? This is 5-volt and then this is 0. Now, there was a moment when I pressed it. Instead of going smoothly from 5-volt to 0, look at what happened. So this can happen either on the rising edge or on the falling edge. Here you can see that this is happening when I released the button because it is moving from 0-volt to 5-volt, and it sort of bounces between 5-volts, comes down. Look at this value here. It's not 5-volt, it's almost 4 point something. So if your logic level is set to treat 5-volt as 1 and 0-volt as 0, then the question is, how do we interpret these values in here? This is one of the problems with the mechanical nature of the switches, and like I explained, this can happen either on the falling edge or on the rising edge. By falling edge, what I mean is when it is transitioning from high to low, that is when I have pressed it. And then from rising edge means when it is transitioning from 0-volt to 5-volt. And this is what the oscilloscope has captured beautifully here. So we can see that this situation happened when I released the switch. So what it means is that if your firmware is fast enough to be able to react to these bounces, then in this state, it's not really going to do what you think it is supposed to do. And the way we solve this is called switch debouncing. There are multiple techniques. One way is to take care of it in code, and another way is to take care of it in the hardware. Now, to take care of it in hardware, a very simple solution is what I'm showing here. So instead of tapping the output right away, you can introduce a capacitor between the switch and the output. And this capacitor here is going to smoothen the bounces that is going to happen, right? You know, a capacitor stores energy, and then when it has the ability to release it, it releases it faster than a battery does. So when the bouncing is happening, think of it as the same way we use capacitors to filter out noises in circuit. So this capacitor that you introduce here is going to filter out the noise, and then it's going to make it nicer. So always have this picture in mind whenever you are pressing a button. Know that because of the mechanical nature of it, it is not going to transition between high and low smoothly. And many times this bouncing is going to happen. So you either take care of the bouncing in hardware like I showed you with the capacitor, or you take care of it in your code. And as far as taking care of it in code is concerned, I'm going to leave that to you as an assignment. Go out there, see what techniques are available to take care of switch debouncing in software. Thank you very much for watching this, and I will see you in the next video.